the value of e raised to 2 plus iota is, and they have given us 4 options, all in terms, mostly in terms of e or e square or e raised to minus 2, and the third option is cos 1 plus iota sine 1. So definitely I have to convert this into a polar form, right? How are we going to do this? Let's find out. So the complex number given to us is e raised to 2 plus iota. This complex number I'm taking, let us say this is z, and e raised to 2 plus iota can very well be written as e square into e raised to iota, right? Now, e square is a real number. What about e raised to iota? Well, that can be expressed in polar form. How? Well, if we write e raised to iota as e square, sorry, the complex number again as e square into e raised to iota multiplied by 1, that means my value of theta is 1. And what is the formula for e raised to iota theta? I mean, how can I convert Euler's form to the polar form? I hope you remember e raised to iota theta can be written as cos theta plus iota sine theta. That's correct. So we are going to use this formula. So when I substitute the value of theta as 1, obviously that will be in radians. So my complex number will become e square multiplied by, in place of e raised to iota, I'm going to write cos 1 plus iota sine 1. And this will be the representation of complex number in polar form. Clear? Very well. If we check the options, we can say that answer will be B. Understood? A really simple question. Just you have to remember how to convert your Euler's form to Polar's form. Clear, guys? Perfect. Well, moving on. In this question, they have said the set of points in the complex plane satisfying the inequality argument of z minus pi by 2 whole modulus is less than pi by 2. So that means I have to solve this modulus inequality, right? And from there, I'll get a relation, or let us say a range for the argument of z. And if I get range for argument of z, I have to relate whether imaginary part of that complex number will be greater than 0 or less than 0. And similarly, whether the real part will be greater than 0 or less than 0. I have to find the right option from all these 4 which are given to me. How am I going to do this? Well, we'll solve the inequality. But first of all, what you have to remember, if I have to find my complex number in the complex plane, I have to first think about what is this argument of z? Is this a real value or an imaginary value? Well, you know it very well that argument of z is basically theta, which will be a real value, right? It will range from either you can say 0 to 2 pi, or you can say between 0 to pi, and in the third and fourth quadrant, it will lie between minus pi to 0. Clear? Okay, so argument of z is real. This much we have inferred. Now, if this is a real modulus inequality, we can just go back to the chapter where we have read modulus inequalities. Yes, you know how to solve a modulus inequality, right? Suppose if I say that mod of x minus a is less than, let us say, b, where a is a real number, x is a real number, and b definitely is positive. How do I solve this? Well, from here I can say that my x minus a is going to lie between minus b to b. That's correct. Very well, you remember it. Good. And from here we'll just get the value of x, right? Similarly, we are going to solve here also. Let's start with the solution, guys. So what I can say from here is that if argument of z minus pi by 2 whole modulus is less than pi by 2, we have just seen that argument of z minus pi by 2 is going to lie between minus pi by 2 to pi by 2, isn't it? And if I add pi by 2 on all sides, I'm going to get that argument of z will be actually greater than 0 and less than pi. Now, guys, tell me one thing. If I have a complex number whose argument is lying between 0 to pi, that means that complex number is lying in which quadrants? Well, if we actually consider our Argand plane, we know this is my real axis, the positive real axis, this will be my positive imaginary axis. If my argument of any complex number is lying between 0 to pi, we can say that the complex number will definitely be lying in first and second quadrants, isn't it? So if my complex number is lying in first or in a second quadrant, what is the imaginary part? Well, we can say that imaginary part will always be what? Greater than 0, right? Real part can be both positive or negative, but the imaginary part will always be greater than 0. That means finally what we have arrived at is the condition that imaginary part of this complex number is always positive. Understood? Okay. And if we look at the options now, we can say that answer will be A. Is this clear, guys? A really simple question, isn't it? Perfect. Well, moving on, let's see what they have said here. They have asked the principal argument of a complex number. Well, that is written in terms of some factors. The first one is 1 plus iota raised to 5 multiplied by 1 plus root 3 iota whole square. In denominator, I have minus 2 iota multiplied by root 3 minus 1. With a minus sign, again I have root 3 plus 1 multiplied by iota. So this entire is my complex number. I have to find the principal argument of this. They have given us options. How are we going to do that? Well, here again we are going to use the properties of argument. Yes, but before that, let's assume some complex numbers. I'm taking this 1 plus iota, let us say as z1, 1 plus root 3 iota, let us say as z2. And what about this part? Well, if I actually open up this part, this entire term in denominator can be written as 2 iota square, which is minus 1. So I'll have minus 2 multiplied by root 3 plus 1. And then I'll have minus 2 iota multiplied by root 3 minus 1. Is this clear? You have just multiplied the terms. Perfect. So let's assume these complex numbers as z1, z2 and z3. Clear? Now, if I have z1 as 1 plus iota, can I get such argument? Yes, you know tan theta is y by x. It is lying in first quadrant. That means my argument of z1 will be pi by 4. Similarly, another complex number z2 is 1 plus root 3. To write its argument, we know tan theta will be equal to y by x, that is root 3 by 1. So its argument has to be pi by 3, right? Okay, so these two are clear to you. They both are lying in the first quadrant. Coming to z3, well, its real part is negative as well as imaginary part is also negative. That means this complex number z3 will lie in the third quadrant. So my z3 is going to lie in third quadrant, right? And in third quadrant, what do we write the argument as? Well, that value can be written as minus pi plus theta. And what is theta? Well, theta is defined by value of tan theta, which is equal to positive value of y divided by negative value of y. So it's going to come out as twice of root 3 minus 1 divided by twice of root 3 plus 1. Clear? And what this value is? Well, I can say this value actually is coming out as pi by 12. That means if I put my theta value over here as pi by 12, the argument of z3 will be minus pi plus pi by 12. Is this clear, guys? Okay, so my argument of z3 actually is coming out as minus pi plus pi by 12, that is minus 11 pi by 12. Now let's consider this complex number as z, and this z can be written as z1 raised to 5 multiplied by z2 square divided by z3. And from here, if I take argument on both sides, I'm going to get argument of z is equal to argument of this entire part. Now comes the role of properties of argument. What is argument of z1 into z2? Well, that is argument of z1 plus argument of z2. Similarly, guys, tell me one more thing. What is argument of z1 by z2? Well, that value is argument of z1 minus argument of z2. That means I can say from here that my argument of z is going to come out as argument of z1 raised to 5 plus argument of z2 square minus argument of z3. Clear? And from here, one more thing we can say, we know that argument of z1 raised to 5, well, this term can be written as 5 times of argument of z1. Similarly, argument of z2 square, well, this value can be written as twice of argument of z2. Clear? Now we'll just substitute the values of argument of z1 as pi by 4, z2 as pi by 3 and z3 as minus 11 pi by 12 and find the answer. So from here I can say that my argument of z is actually coming out as 5 pi by 4 plus 2 pi by 3 plus 11 pi by 12. Clear? And now what we have to do? Well, now we have to just take the LCM of this. So when we take the LCM, it's going to become 12. Here you will get 15 plus 8 plus 11 pi by pi. And 15 plus 8 plus 11, well, that value is 34 pi by 12. So I can say that my final argument of z is coming out as 34 pi by 12, or you can say 17 pi by 6. But in question what they have asked? Well, they have asked what is the principal argument. And you know how to find principal argument from the argument value? Well, to get the principal argument from the argument, we have to either add or subtract even multiples of pi, such that the principal argument comes in its range, which is actually between minus pi to pi. So how can I get the 17 pi by 6 in the range of minus pi to pi? Well, I can subtract 2 pi from here, right? So when I subtract 2 pi, I'll get my final answer, or let's say the value of principal argument of z as 17 pi by 6 minus 2 pi, which is coming out as 5 pi by 6. This is going to be the final answer for this question. Have you understood? We have just used the properties of argument. Clear, guys? Very well. And if we look at the options, we know that answer will be A. Understood? Well, moving further, in this question they are saying what is the point of intersection of the curves. They have given us two curves. First one is argument of z minus 3 iota is equal to 3 pi by 4, while the another one is argument of 2z plus 1 minus 2 iota is equal to pi by 4. What is that value, or let us say what is the point of intersection is what we have to find. Okay, how are we going to solve this out? Well, before going to the question, let us understand what this part actually means. Well, we have learned this, right? In the chapter, when we have read the geometrical interpretation, what is argument of z minus z naught is equal to theta represents? Well, it is basically represented by a ray. Yes, a ray on which my z can lie, but the ray is emanating from point z naught. So I have a ray which is emanating from my complex number z naught and is inclined at an angle theta with positive real axis, isn't it? Z can lie anywhere on this ray. Is this clear? If my theta is positive, obviously angle has to be measured in anti-clockwise sense. If my theta is negative, it's measured in the clockwise direction. Have you recalled this much? Perfect. So let's start with the first equation which they have given it to us in the question. Argument of z minus 3 iota is 3 pi by 4. That means I have a ray which is starting from my point 0, 3. Right? And is inclined at an angle of 3 pi by 4 with x-axis, or a line parallel to x-axis. So can I get equation of this line? Well, yes, I can get equation of this line. If the angle is 3 pi by 4, I can say that this line L will have slope as minus 1. Isn't it? Tan 135 degree is minus 1. So if slope is minus 1 and it's passing through the point y is equal to, 0, 3, I can directly say that equation will be y is equal to minus x plus 3. Which form have we used? Slope intercept form, that's correct. So this is equation of my first line. Is this much clear? Perfect. So we have got that my first curve actually represents a ray which is emanating from point 0 comma 3 and equation of this ray is y is equal to minus x plus 3. You have to remember z is lying only in this portion. It is not below 0 comma 3 on the in the first quadrant side, right? Okay, so this will be my locus of z by the first curve. Similarly, if I go to my second curve is written like this. So here I'm writing it as argument of twice. I'm taking 2 common. So it's z plus 1 by 2 minus iota. This entire thing is equal to pi by 4. Now guys, tell me one thing. What is argument of z1 into z2? Well, if we recall the property, argument of z1, z2 is nothing but argument of z1 plus argument of z2, isn't it? So this can be written as argument of 2 plus argument of z plus half minus iota. Is this much clear? And now tell me, what is argument of 2? Well, 2 lies on positive real axis. That means its argument is nothing but 0. That means I can say that I am finally left with what? Well, I am left with the condition that argument of z plus 1 by 2 minus iota is equal to pi by 4. Or further, I can say that you can write it like this: argument of z minus half plus iota is equal to pi by 4. And now again, by the same concept, we can say that this will represent a ray which is emanating from point minus half comma 1 and is inclined with real axis, or a line parallel to real axis at an angle pi by 4, isn't it? So I have a line, let's say here is my point minus half comma 1. A ray is somewhat like this, inclined at an angle pi by 4 with this. Is this clear? Can I write the equation of this line? Well, yes, I can write the equation of this line also. My equation, again, I can say it can be written as y minus y1 is equal to m. Now, if it is inclined at angle 45 degree, what is the slope? Well, that is 1, right? So, it is 1 times of x plus half, or I can say that equation of line will be y is equal to x plus 3 by 2. Is this much clear? Perfect. So I have my second curve also ready with me, and the equation of the curve will somewhat look like this. Now I have to find intersection of the first and the second curve, or let's say the first and second equation. I hope this you can solve really very easily. I have y is equal to minus x plus 3 and y is equal to x plus 3 by 2. So if I equate these two parts, I'm going to get 2x is equal to 3 by 2. That means x will be equal to 3 by 4. Right? But is it possible? No. Well, x is equal to 3 by 4 will come in my first quadrant. And we have already seen that these two green rays, they are not going to intersect because z cannot come beyond this point. Right? So therefore, I can directly say that by my graph also, that these first and second curves, or let's say the first and second rays, they are not going to intersect at all. And if they are not going to intersect, we can say from the options that answer is going to be D. Is this clear? Have you understood? Well, moving further, in this question, they have given us a equation. If modulus of z minus 2 minus iota is equal to modulus of z multiplied by modulus of sine pi by 4 minus argument of z, what is the locus of z? Is it a ray, a part of a circle, a part of a parabola, or a part of an ellipse? How should I solve this? Well, since they have given us a relation between modulus, what we can do is, let's start by considering z as something. You can either consider in polar form or in Cartesian form. So, when I, let's say, consider my z as x1 plus iota, so when I consider my z as x1 plus iota y1, can you tell me guys what is my left hand side? Modulus of z minus 2 minus iota. Well, actually this represents distance between two 2 points. One point is z, another point is 2, 1, right? So this is representing distance between my complex number z and 2 plus iota. So I can say that my left hand side is going to become modulus of x1 minus 2 plus iota times of y1 minus 1. And this further can be written as root over x1 minus 2 whole square plus y1 minus 1 whole square. Is this clear? Okay, this is my left hand side, distance between 2 points. Coming to my right hand side, let's take z here in polar form. It's r cos theta plus iota r sin theta. We know the modulus is r while the argument is theta. So when I write my right hand side, it's going to become r multiplied by sine of pi by 4 minus theta whole modulus. Let's expand this part. What is sine of a minus b formula, guys? Well, sine of a minus b is sine a cos b minus cos a sine b, isn't it? So this is going to become r sine pi by 4 is 1 by root 2 into cos theta minus r. Then I'll have cos pi by 4 again 1 by root 2 multiplied by sine theta, right? Sine theta, right? Now if I compare z x1 plus iota y1 form and the polar form, we can clearly say from here that x1 will be equal to the r cos theta part, while y1 will be equal to the r sin theta part. So my right hand side finally is coming out as modulus of x1 minus y1 by root 2. Now, what actually have we got? Well, on left hand side we have got distance between 2 points x1 comma y1 and 2 comma 1, while on right hand side I have got distance between point x1 comma y1 and a line. Yes, what is the equation of a line? Of this line, guys? Well, it is x minus y is equal to 0. You remember the distance formula. So, finally, I'm repeating it again for you. I have to find locus of my point z having coordinates, let's say x1 comma y1, such that distance of z from a point is equal to distance of z from a line. Distance of z from a point is equal to distance of z from a line. Does anything ring? Where have we read this kind of, equation, or let's say a locus? Conic sections, that's correct. You can say it's somewhat like PS is equal to PM, isn't it? PS is distance between my point P. In this case, let's say it's x1 comma y1. S is the focus, that is 2 comma 1. And PM is nothing but distance between my point x1 comma y1 and the directrix having equation x minus y equal to 0. So if I have arrived at this relation, I can say that locus of my point z will be nothing but a part of parabola, right? A really simple question, isn't it? Perfect. And if we see the options, we can say answer will become C. Have you understood? Very well.